Hello everyone, in this video lecture we are going to study what displacement time graph. It is a graph between displacement and time. We know that the velocity of a body moving along a straight line is given y. Velocity is equal to, it is the time rate of change of displacement, that is displacement of the body per unit time taken is known as the velocity. So by rearranging this, we get displacement of a body equal to velocity multiply time taken. Now in the next step we have to calculate of the velocity from this velocity time graph. Here this is a velocity time graph. Here I take along x-axis time and along y-axis displacement x. The graph between displacement and time is a straight line graph. Here on this graph, let us consider 2 points B and C on the displacement line graph. Now from point B and C, draw perpendicular on time axis and displacement axis also. When time is t1, then the displacement covered by the body is x1, and when time t2, then the displacement covered by the body is x2. Now extend this line up to this point D. So in this way, this is a triangle BCD. Now here CD, this is equal to x2 minus x1, and BD equal to T2 minus T1. You may write in this way: determination of the velocity from the displacement time graph. For this, consider 2 points B and C on the displacement time graph. Let x1 and x2 be the displacement of the body in the time t1 and t2 respectively. Then the displacement of the body in the time interval t2 minus t1, and it is equal to x2 minus x1. We know that velocity, it is equal to displacement over time. So from graph, when we take here triangle BDC, so here displacement is x2 minus x1 and time is t2 minus t1, and this is equal to, this is the change in displacement, that is written y del x, and t2 minus t1 the change in time, and it is taken as del t, and this is equal to, here x2 minus x1 equal to del x, and this is equal to CD, and t2 minus t1 is del t, and it is equal to VD. So this can be written as del x is equal to CD and del t is BD. Now you can see here, if we take this right angle triangle BDC, so here tan theta perpendicular over base. Here perpendicular is, if we take this angle theta, then perpendicular is CD and base is BD. So tan theta is equal to CD over BD, and this is equal to slope of displacement time graph. Tan theta is equal to CD over BD, and which is equal to slope of the displacement time graph. Therefore the velocity of a body having uniform motion is equal to the slope of a displacement time graph.